All right, so Z-score is part 3. So we've talked about what a Z-score is, the number of standard deviations from the mean that any individual score represents. We've talked about how to calculate it, that score minus the mean divided by the standard deviation. And we've talked about why they can be helpful, right, in seeing which scores are outside the range of normal. Now, it's important to note that a z-score can be bigger than 3 or lower than -3. And with it, that is one correction I wanted to make. With this 2%, it's not necessarily saying between 2 and 3. It's saying higher than 3, lower than -2. The reason we put our cutoff at 3, you were introduced to a term called an outlier in the last chapter. I believe they defined it in chapter 2. An outlier is a score that is statistically unusual in your data set. And a lot of times we'll define an outlier as one that is either above this 3 or below this -3. So an outlier is an unusual score. Let me give you an example. Let's say I polled all of you and I asked you, how many hours a week do you work? The fact that you're taking classes online, we would probably expect the average to be 40 hours a week. A lot of you have full-time jobs. Some of you work part-time, but let's say we would expect the average to be 40. And maybe we would expect the variability to be somewhere between 20 and 50. Okay. Now, let's say, for example, that there was a physician in this class. Maybe they were taking a stats class because they were planning on doing some research, writing some grants, needed to brush up on it. So let's say we had somebody in this class that I did this poll of how many hours do y'all work? And somebody responded back with 95, right? They'd be several standard deviations away from the mean. They would be an unusual participant in this class. They would be an outlier. And so from there, we would have to decide, okay, so if I'm going to do some research based on your work hours compared to your grades, things of that nature, would I want to include this participant? Are they different enough from the data set that they should continue to be included? Or should I exclude them from my statistical analysis? And this is why knowing the variability and the standard deviation is so important, because the reason I would know that 95 hours was unusual, was going to be a exceptionally high z-score, would be compared to the rest of you. Let's say I went and did that same survey over here at one of the local hospitals, right? You have your people who work 40 hours a week, that work front desk, that do billing, that do coding, that do scheduling and all that. But you also have a lot of people at the hospital, nurses that are picking up extra shifts for overtime, physicians that have no measurable, predictable schedule. There would be lots of people there that were probably working 70, 80, 90 hours a week. And so in that setting, that result of I work an average of 95 hours a week would no longer be that unusual. It would probably still be a pretty high z-score, but it might no longer be an outlier because there's more people in that data set that are similar to that. My data set would have more variability. My standard deviation would probably be a lot bigger, since I would have some part-time 20-hour-a-week people at the hospital and some positions working 80, 90, 100-hour weeks. But so this is why z-scores are important. They let us find participants that are clustered around the mean, that are higher or lower than the mean, but are still within the expected numbers that we would plan on seeing in a data set, versus the one that's okay, there is something unusual about this particular result in my data set. And again, that is called an outlier. And as a general rule, a z-score that is higher than 3 is considered to be an outlier, a univariate outlier. There's also multivariate outliers, which I might talk about a little bit later in the semester. But that is the practical use of z-scores. I'll show you how to calculate them in the software.